30 years, multiple blue ribbon, oh, there it goes. Could y'all hear me before? Okay. Over the past 30 years, multiple blue ribbon panels, presidential commissions, and advisory bodies have consistently set the moon and Mars as goals for our human exploration programs. And as I've said before, I want Americans to be the first to set foot on the red planet. Sending Americans to land on and explore the surface of Mars is a monumental and worthy goal, one I believe we should embrace. Taking that giant leap will require every ounce of this nation's commitment and capability. The critical questions before us now are what decisions and actions are needed to structure a Moon and Mars program for sustainability and success. We're here today to seek the guidance and perspectives and deep expertise of two eminent witnesses, one Apollo astronaut and lead of one of the foundational studies on the Moon-Mars program, and a former industry executive and director of NASA's Goddard Space Flight Center. They both have unparalleled depth and breadth of experience in human spaceflight, industry, and NASA programs. They have faced the hard technical challenges, seen what has worked and what hasn't. The lessons they have learned and their wisdom are critical to our work here today. We know that the road to sending American astronauts to Mars will require a commitment, dedication, and direction that continues across many Congresses and administrations. It is our job today to lay out a course that ensures consistency through these changes in leadership. Achieving such an audacious endeavor requires ambitious yet realistic expectations and expectations and the planning, leadership, workforce, and resources to increase the probability of success. Anything else runs the risk of perpetuating a cycle of human exploration visions left unmet. The United States has led space exploration for over half a century. Our leadership role has changed the way we interact with the world and the way the world perceives us. However, we cannot take our leadership for granted. Today, our nation has been without a domestic capability for sending humans into space for nearly a decade. At the same time, there are an increasing number of nations and private entities that are actively utilizing and growing their investment and capabilities in space. It is critical that we move beyond low Earth orbit and that we do it sustainably, affordably, and safely. Any void we leave in that regard, others will fill. The bottom line is we have a choice. Do we want to lead or do we want to follow? Following is not the legacy our Apollo heroes deserve, especially as we celebrate the 50th anniversary of the moon landing. Nor is it a future that ensures the leadership, safety, and national security of America in space. Leading requires consistent purpose and direction, carrying out and achieving complex and challenging goals, and leading with partner nations and commercial industry in the peaceful exploration and uses of outer space. Over the past 20 years, we have had a taste of the cost and effort involved in leading and maintaining long-term human spaceflight activities. Developing, assembling, and operating the International Space Station took over a decade to complete and represented a U.S. investment of over $80 billion, and it requires about $3 billion a year to support. Getting to the moon and Mars will require much more. The decisions we make today about the structure of the Moon-Mars program extend beyond the next handful of years. They are about what we set up for future generations. In a July 2019 article in Physics Today, one stakeholder stated, despite its successes, Apollo was canceled due to its expense, and NASA lacked any follow-on program. That is why it is imperative that we take this opportunity to hear from our witnesses on what it takes to create a sustainable and effective pathway towards sending humans to the moon and Mars. We, as a nation, know what we are capable of achieving. We've landed humans on the moon, supported humans living and working in space continuously for almost 20 years, landed and operated spacecraft on the surface of Mars, and much more. We must build on these hard-earned lessons as we look for innovative and expeditious ways to achieve our goals while also ensuring the responsible use of taxpayer resources. It is our role on the subcommittee and the committee to structure a program that's in the best interest of the country and has the greatest likelihood of success. Before I close, I also want to make clear that our focus today and in other exploration hearings in no way minimizes the importance of NASA's science, space, technology, and aeronautics programs. All these missions contribute to NASA's success, and we need to ensure that they remain healthy and strong. I am excited to hear from our witnesses today and glad to work with my colleagues on both sides of the aisle to ensure that NASA and our human space exploration programs are set up for success both now and into the future. I now recognize Ranking Member Mr. Babin for an opening statement.
Thank you, Madam Chair. I appreciate it. This summer, we celebrated the 50th anniversary of the Apollo-11 moon landing. And rather than resting on our laurels, the Trump administration challenged NASA to return to the moon on its way to Mars. This is an audacious goal. For over 15 years, multiple Congresses, controlled by both Republicans and Democrats, have passed authorization acts that directed NASA to do the exact same thing. All of these acts directed NASA to explore the moon, Mars, and beyond using a stepping stone approach. The laws directed NASA to efficiently develop technologies and architectures that enable further exploration and prevent dead-end technologies and missions. The laws direct NASA to leverage the expertise at NASA centers and the work done on the Space Launch System and Orion crew vehicle that employ technologies derived from taxpayer investments in the Space Shuttle program. Finally, Congress consistently directed NASA to explore deep space on a timetable determined by the availability of funding. The National Space Council, led by Vice President Pence, has adopted those principles for the Trump administration. Space Policy Directive 1, or SPD-1, directs NASA to lead an innovative and sustainable program of exploration. SPD-1 also directed NASA to lead the return of humans to the moon for long-term exploration and utilization, followed by human missions to Mars and to other destinations. The administration should be commended for subsequently challenging NASA to achieve this goal by 2024. For several years, NASA has lacked a sense of urgency. Without a worthwhile near-term goal, our nation's space enterprise lacked consistency and lacked focus. This allowed the previous administration to slash early-stage funding for SLS and Orion and to propose cuts year over year, stretch out development schedules, scale back capabilities, impose unique accounting rules like termination liability, and to hold up the purchase of long lead items during continuing resolutions. We now have bold leadership that is empowering NASA to lean forward. NASA recently issued a broad agency announcement soliciting proposals for a human landing system within 30 days. NASA directed contractors to not only propose landers that can launch on commercial launch vehicles. This is despite the fact that every space exploration study conducted over the last 40 years indicated that the most optimal architectures for exploring the moon and Mars require a heavy lift launch vehicle similar to SLS. This strategy also fails to leverage the investments the taxpayer made over the last decade. While I share the frustration and delays to the SLS program, switching horses midstream is not a wise move at this point. The Aerospace Safety Advisory Panel and the National Academies have all reported that one of the largest risks to the success of our human exploration program is a lack of consistency. It's also fair to note that other human exploration developments like commercial crew are also behind schedule. At our last space subcommittee hearing, NASA said that maintaining the 2024 date for a lunar landing is unlikely if they do not receive the additional funding that they requested in their budget amendment. If a recent House Appropriations Committee hearing is any indication, the likelihood of receiving additional funding this year is dwindling. If this forces NASA to reassess its schedule for returning to the moon, it would provide an opportunity to ensure that they are developing the ideal architecture that maximizes mission success and minimizes risk. This could be done by developing landers that leverage the investments already made by the taxpayers in national capabilities like SLS and Orion, and then relying on the private sector to contribute augmenting cargo capabilities and delivering precursor science payloads to the lunar surface. By this time, NASA may have concrete funding details and a more refined acquisition strategy. I look forward to working with the administration and my colleagues on both sides of the aisle here in Congress to make Artemis a success. I'd like to thank our two very distinguished guests and witnesses today for their service and to look forward to their testimony. So I yield back the balance of my time, Madam Chair, and thank you.
Thank you, Ranking Member. The Chair now recognizes the Chairwoman of the full committee, Ms. Johnson, for an opening statement.
Thank you and good afternoon. I want to welcome both of our distinguished witnesses to today's hearing. Neither of you is a stranger to this committee. We have benefited from your thoughtful perspectives and advice on multiple occasions, and I have no doubt that will be the case again today. Your testimony comes at a particularly significant time. This committee will be reauthorizing NASA this Congress, and a program of human exploration beyond low Earth orbit that will ultimately take America to Mars is something we will be considering. I support a robust program of exploration that leads to Mars, but it needs to be one that is sustainable. Unfortunately, based on the limited information provided to date, the administration's 2024 Lunar Landing Directive appears to be neither executable nor directive that will provide a sustainable path to Mars. Proponents of the administration's crash program may argue that such a deadline will instill a sense of urgency and motivation into our space program. However, an arbitrary deadline that is uninformed by technical and programmatical realities, that is unaccompanied by a credible plan, and that fails to identify the needed resources in one that sets NASA up to fail rather than enabling it to succeed. Not only does that do the hardworking men and women of NASA and its contractor team a real disservice, but it will wind up weakening American leadership in space rather than strengthening it. That is why I'm glad that Chairwoman Horn and the Space and Aeronautics Subcommittee are taking the time to strip away the rhetoric and examine what will actually be required to carry out a sustainable and effective program of human exploration leading to the first crewed landing on Mars. And I can think of no better witnesses to help us understand what will be involved than the two individuals before us today. Each of them has decades of experience in aerospace, and they speak with deep understanding of what will be needed to successfully carry out an ambitious program for human exploration. That doesn't mean that we should simply try to recreate Apollo program. Apollo was a unique undertaking carried out during a unique time in our history. But we do need to understand the factors that made Apollo and other major spaceflight programs successful, including a skilled management team, a hard-nosed approach to design and operations and risk, an understanding of the pros and cons of the available technological options, a commitment to testing and a willingness to commit the necessary resources. As we embark upon this generation's human exploration adventure, we face many of the same challenges as those who led Apollo faced. While we need not be bound by the past, we do need to take heed of its lessons, some of which were painfully learned. In closing, I believe that my friends and colleagues on both sides of the aisle want a human exploration program for America that is bold and visionary and worthy of our great nation. I believe we can have one if we take the time to get it right. This hearing is an important step in that process, and I look forward to our discussion. Thank you, and I yield back.
Thank you, Madam Chairwoman. And at this time, the chair recognizes Ranking Member and fellow Oklahoman, Mr. Lucas, for his opening statement and introduction of another fellow Oklahoman.
Thank you, Madam Chair. Tomorrow marks the 50th anniversary of Apollo 12's launch. November 14, 1969, Pete Conrad, Alan Bean, Richard Gordon set off on humanity's second mission to the lunar surface. Despite harrowing winds and lightning strikes that overloaded the spacecraft's fuel cells during the launch, the mission's success proved that America's resolve to explore space. It demonstrated that Apollo 11 wasn't a fluke or a one-time achievement, but rather the dawn of a new era for mankind. The missions after Apollo 11 may not have been as celebrated, but they solidified America's leadership in space and were just as valuable to our studies of the moon. But what if we did not return to the moon after Apollo 11? And thankfully we did, and we followed that up with a string of successful launches culminating in Apollo 17. Unfortunately, we haven't been back to the moon since Gene Cernan left his daughter's initials in the lunar dust in 1972 on Apollo 17. That's 47 years, nearly a half a century. I can't help but draw comparisons to the current state of human space exploration. Rather than canceling a return to the moon by saying we've been there before, the Trump administration set a bold course to return to the moon and assure American leadership in space. Just as Apollo 12 affirmed America's resolve last century, the administration's plans to return to the moon will demonstrate our resolve and leadership in this century. This is because we have the potential to learn much more now than we did a half a century ago. Just last week, NASA scientists opened an untouched sample of lunar rocks collected during Apollo 17. We kept those samples preserved for nearly 50 years because we knew our technology would advance rapidly in the years following Apollo 17, and we could learn more from analyzing them now in pristine conditions than we could have at the time. Similarly, returning to the moon now will help us develop the technology necessary to land humans on Mars. It will allow our astronauts to learn how to operate in deep space and on the surface of another world only a few days away, rather than months or years away. The Artemis program has already energized the NASA workforce, motivated contractors, inspired scientists and students. Artemis will require marshaling our nation's best and brightest, as well as significant contributions from our international partners and the private sector. This is a worthwhile task because great nations do great things. As we set forth on our return to the moon, we should always be mindful of the lessons we learned from Apollo and the decades that followed. Progressing incrementally on successful achievements, limiting the number of mission elements to decrease risk, and maintaining consistency of purpose are lessons that are just as relevant today as they were 50 years ago. Luckily, we have two great witnesses who I'm sure can add to this list for us. And as the chairman noted, one of those witnesses is a fellow Oklahoman, Lieutenant General Thomas Stafford, retired. He grew up in Weatherford, Oklahoma, which I proudly represent. And after attending the Naval Academy and serving as an Air Force test pilot, he was selected for astronaut group number 2 in 1962. He went on to fly aboard Gemini 6A, Gemini 9, Apollo 10, and Apollo-Soyuz test project. He served as a director of the astronaut office, commanded the Air Force Flight Test Center in Edwards Air Force Base, and was Deputy Chief of Staff, Research, Development, and Acquisition at the Pentagon. Since retirement, he served as the chairman of the International Space Station Advisory Committee, chaired the synthesis group that produced the report entitled America at the Threshold on the Space Exploration Initiative. His awards are too numerous to mention, but probably his finest accomplishment is being born in western Oklahoma, where, I would note, his namesake, the Stafford Air and Space Museum, resides. I'm proud to call him a constituent, a friend, a confidant. Thank you for holding this hearing, Madam Chair. I yield back the balance of my time and look forward to the testimony.
Thank you, Ranking Member Lucas. It is truly an honor to have you both here today. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. And without objection, I'm submitting for the record a letter from the Planetary Society. Okay, wonderful. So we've had an introduction of one of our witnesses, and I have to say that one of the really fantastic things about the work that we get to do on this committee is that we're doing the work of the nation, and we're doing it in a way that exemplifies what we should be doing, working in a bipartisan manner to address the issues ahead of us and set this up for success. And that includes the recognition of the witnesses in front of us today that I don't think you'll find any disagreement about the expertise and the experience of our witnesses. And I'd like to take a moment now to introduce our other distinguished witness who, like General Stafford, has his own remarkable career. Our second witness today is Mr. A. Thomas Young, former NASA Goddard Director and Aerospace Industry Executive. Mr. Young began his career at the Langley Research Center, where he was the Mission Director for Project Viking, which successfully landed 2 Viking spacecraft on Mars. He also served as the Director of the Planetary Program at NASA headquarters and as Deputy Director of NASA Ames Research Center. He then went on to become Director of NASA's Goddard Space Flight Center. After leaving NASA in 1982, Mr. Young transitioned to industry and became President and Chief Operating Officer of Martin Marietta Corporation, an aerospace manufacturing corporation that later merged with Lockheed Corporation to form what is now known as Lockheed Martin Corporation. Mr. Young is a fellow of numerous prestigious organizations, including the American Institute of Aeronautics and the American Astronautical Society, the Royal Astronautical Society, and the International Academy of Astronautics. Mr. Young received both a bachelor's degree in aeronautical engineering and a bachelor's degree in mechanical engineering from the University of Virginia. He also received a Master's of Management degree from MIT and an honorary doctorate of science from Salisbury University. Welcome, Mr. Young. As our witnesses, you should know you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing, and when you have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel, and we'll start today with General Stafford. General Stafford, you're recognized. General, if you could push there you go.
There we go. Should have led the checklist. Chairwoman Horn, Ranking Member Babin, committee members, and also full committee Chairwoman friend Bernice Johnson and Ranking Member Lucas. Thank you for this opportunity for address the current state of NASA exploration beyond low Earth orbit. And over the years, I've had the opportunity to testify before both the subcommittee and the full committee here for many years. And I've always applauded this subcommittee and the committee for your continued bipartisan support for the guidance and the legislation to ensure the United States has a strong world leadership in space exploration. And going back a few years to the NASA 2010 authorization bill, it was really superb to see the bipartisan work of both the House and the Senate, and then the House and the Senate working together that gave us the authorization under which we have the SLS and the Orion spacecraft today. And from my observation of that, being somewhat a little bit involved in that, if all the members of this United States Congress, the House and the Senate work like that, the congressional approval rate would be up in the 60 or 70%, believe me. But that 2010 authorization bill was just superb. And say thank you for all the help. As pointed out, this is the 50th anniversary of the Apollo program that I remember so well, and it was 50 years ago that I flew to the moon there as commander of Apollo 10. And also to Congressman Lucas, I certainly appreciate those kind words of introduction for just a redneck, gray-haired space cowboy from western Oklahoma. And, but as we look at where we are going forward in this effort, it's going to be difficult. It's going to be tough. And I'm reminded of the words of the great writer George Santayana, to paraphrase it: those that ignore the lessons of history are doomed to repeat them. And as we start down here with the Artemis program, we have to be aware of all the triumphs and the tragedies that we've had in the past. Now, in 1989, the 20th anniversary of Apollo 11, President George H.W. Bush gave a speech on the steps of the Smithsonian Space Museum. He set the space policy for returning to the moon after the turn of the century then, and then back to stay, he said, and then eventually a manned mission to Mars. That became known as the Space Exploration Initiative. And Vice President Quayle was then appointed to activate the National Space Council. And after a couple of small studies, I was asked by Vice President Quayle and President Bush if I would chair a committee to put together and synthesize the ideas of how to go back to the moon, on to Mars in a way that's faster, better, safer, and lower cost. So I donated about 60% of my time, had 2 floors of people over in Crystal City, 45 people full-time. We had people from all around the United States, industrial firms come in. And at the end of 11 months, the Vice President and I had a joint press conference at the White House and unveiled this book, which is kind of known as the Bible for exploration beyond low Earth orbit, called America at the Threshold. And one of the major things that came out, my charter was 2 or more architectures and the technology priorities. We had 14 technology priorities, and we ended up with 4 architectures. But the number one was that this country build a heavy lift booster that would go from 150 metric tons to grow to 250 metric tons. And we outlined this out of parts and pieces from the Saturn V to reduce the cost. And hopefully we will be able to get there someday, even though the booster we have now is small compared to that. Thank you, Madam Chairman.
Thank you, General Stafford. Mr. Young, you're recognized.
Chairwoman Horn, oops, I also missed the cue. Chairwoman Horn, Ranking Member Babin, and committee members, and Committee Chairwoman Johnson, and Ranking Member Lucas, I'm pleased to have the opportunity to present my views as to the critical actions necessary to maximize the probability of success of the Mars-Moon Human Exploration Program. Mars human exploration with humans to the moon as preparation is one of, and perhaps the most challenging, exciting, and potentially rewarding exploration endeavors ever undertaken. The challenges and risks cannot be overstated, nor can the excitement and anticipated extraordinary rewards. It is a bold and achievable endeavor that the United States should pursue. Business as usual will not be adequate to successfully implement the Mars-Moon program. The best of the best will be required. Extraordinary actions will be necessary, requiring that the program have high national priority. NASA has exceptional Moon and Mars experience with sophisticated robots at the Moon and Mars and humans on the surface of Mars. No one else, domestic or international, has this breadth and depth of exploration experience and capabilities. The challenges of the Moon-Mars program are such that the leadership capabilities of NASA must be augmented. Additional senior, experienced, leadership from other government organizations, industry, and academia will be needed, as was the case for Apollo. Strengthening the NASA workforce will also be necessary. Half a century has passed since Apollo making that experience less relevant. A workforce experienced in the development and execution of large, complex space projects will be required. The International Space Station, Orion, SLS, and the Mars robotic program have contributed significantly to workforce development. I believe the most important role for the lunar phase is additional workforce experience. Mercury, Gemini, and Saturn V clearly were important contributors to workforce development for Apollo. The United States aerospace industry has implementation capabilities that are second to none. Utilizing the implementation capabilities of industry in partnership with the breadth of NASA experience will be critical to achieving program success. More specifically, the full capability of NASA and industry will be required. Management and contracted experiments must be excluded from the Mars Moon program. Implementation will be at the limitation of our capability without the additional complications of management and contracting experiments. A clear, unambiguous goal is required. Is the lunar part of the program to support success at Mars, or is it to achieve sustained lunar presence? Does the Mars part of the program have specific objectives, such as a Mars orbital mission followed by boots on the ground, or is it a long-range objective? Answers to these questions will have a profound impact on schedule, cost, and a reasonable timeline for humans to Mars. A clear, unambiguous goal must be followed by a detailed plan that is consistent with the goal and developed by the Mars Moon program leadership. A detailed plan is the glue that integrates the vast array of Mars Moon participants into the incredible team necessary to implement the Mars Moon program. Additionally, a detailed plan is necessary to rally support, develop a credible budget, and obtain program and budget approval. Obviously, a budget is required. To be credible, the budget must fund the most probable cost of the program. My understanding of NASA policy is that the most probable cost is defined as a 70-30 cost estimate. The budget should be phased by fiscal year, consistent with the work plan associated with the detailed plan discussed earlier. This will result in a budget profile that is a bell-shaped, with higher fiscal year funding required in years with development, manufacturing, integration, and testing. Flat budgets with a relatively equal funding each fiscal year is the least efficient program management approach. A flat budget approach can result in years of scheduling delay and potentially the doubling of project cost. Obviously, a flat budget should be avoided. Today, NASA's human spaceflight program plate is full. It includes ISS, commercial cargo, commercial crew, low Earth orbit commercialization, the new commercial space paradigm, etc. All are demanding activities. SLS, Orion, and Gateway are challenging elements of the human spaceflight endeavor. In my opinion, the inclusion of the Mars Moon program makes the portfolio of human spaceflight activities unachievable with an acceptable probability of success. Priorities and most likely the termination of some activities will be clearly required. The Mars Moon program is clearly the most challenging and difficult civil space program ever undertaken. Success will depend upon the recognition of the challenges, difficulty, and risk. Success will depend upon the implementation of extraordinary actions necessary to have a sufficient high probability of success. In summary, the actions include NASA leadership augmentation, strengthening NASA workforce, full utilization of NASA and industry capabilities, avoiding management and contracting experiments, a clear and unambiguous goal, a detailed plan, a budget consistent with the most probable cost estimate, prioritization of human spaceflight activities, and elimination of current human spaceflight activities necessary to assure the required resources are available for implementation of the Mars-Moon program. The Mars-Moon program, while bold, is achievable. Extraordinary actions will be required to assure success. A business-as-usual approach will most likely end in failure. The absolute best of NASA, industry, academia, and our international partners is required. Thank you.
Thank you, Mr. Young. The chair now recognizes herself for 5 minutes. Again, thank you both for your breadth and depth of experience and expertise. I think it's clear that we are facing some important challenges in addressing both how we set the program up from a standpoint of authorization, but also funding. And so I'd like to start, Mr. Young, with a couple of your comments and looking at the current program that NASA is undertaking. You touched on a couple of these things, but I'd like to follow up. What would it take at this point under the current program to enable a lunar landing by 2024? Is that at this point something that you think we can achieve in that time frame?
Clearly the budget, which you've touched on, but of the items that I've mentioned, one is it's going to take some extraordinary leadership, and NASA has exceptional capability today, but not enough. So the NASA leadership needs to be augmented somewhat in the manner that Apollo was done. I mean, I recall on Apollo, General Sam Phillips, a four-star Air Force general, was brought over to lead the activity. George Miller from industry was brought over. Bellcom was established by AT&T at Bell Labs to support NASA at headquarters, and they actually ended up having 500 people involved in that activity. So staffing is a critical item. I guess the other item, I mean, I've went through a list, but the other item is the plate is really full today. And if we compare us with the Apollo era, you know, it was basically Apollo, which were following Mercury and Gemini. I mean, today, the array of things that NASA is charged with doing is overwhelming. And I personally think that the leadership is going to have to, number one, prioritize, but number two is probably to eliminate some of the things that are currently being done that will interrupt having any opportunity of 2024, or I would say even 2028, without making those kinds of decisions.
Thank you very much. And General Stafford, I want to follow up. I think it's remarkable that your 19, the work you did in 1991 is still so instructive and informative today, and the time and effort you put into that. So in that report, you talked about accomplishing the necessary system demonstrations and preparations on the moon prior to attempting a challenging Mars mission. Do you still believe that a stepping stone approach is the best pathway to send humans to the moon?
Push the button, right. Chairman Horn, absolutely. This was looked at in depth, and you know, we looked at ways. At first, we could just go direct to Mars, and the more we looked at it, and this was a whole group of all types of input, you'd do a series of things on the moon that would be similar to Mars. In fact, you could use Martian hardware on the moon. The moon has got 1/6 G. Mars has 38% of G of Earth's gravity. And we would actually could simulate it up to certain days and all this. So there's so many things to do and work out the unknowns. And so the answer is yes, it's go to the moon first and then Mars. You wouldn't launch from the moon, you'd launch from the Earth to go to Mars. But you could work out so many of the problems.
Thank you. And following on that, General Stafford, you mentioned, and this is also in your report, the essential need for heavy lift vehicle. Can you speak to how heavy lift vehicle, why it's important, and how it affects the systems and decisions, such as the human landing system?
Right. For the members of the committee, just to review, goes back to Tsiolkovsky's law, a simple three-term equation. On Gemini, it weighed 315,000 pounds at ignition. I went into orbit in that Gemini at a little less than 8,000 pounds. I had 2% of the mass of ignition that I was in orbit. Now, on Apollo, because we had hydrogen in the upper stages, it was more efficient. It was later on in technology. But when I went to the moon, I had 6.4 million pounds at ignition, into orbit with 300,000 pounds, about of which a large part was hydrogen to take it, and oxygen to take us out there. So, but I had 4.8% in orbit, Earth orbit, low Earth orbit, of what I ignited with. And then we ignited after 1.5 revolutions around the Earth to go on a trans-lunar injection, which picked up 11,000 feet per second. When that shut off, then I had a useful payload of 100,000 pounds, the lunar module and the command and service module. That was 1.6% of what I started with. So if you, just for weight alone, if you don't have a big booster, you're not going to make it. But also, so important, it's often left out of, besides just weight, is the size. You need a big payload shroud to carry the rovers, the habitats, the infrastructure. You have to have a big shroud, which leads you to a big, wide diameter booster. If you don't have it, you're not going to make it.
Thank you very much, General. My time has expired to recognize Mr. Babin for 5 minutes.
Thank you. General Stafford, previous administrations have argued that we should not return to the moon because we've been there before. Would you feel more comfortable conducting a mission to the moon to test systems for an eventual Mars mission? Or would you prefer to skip directly to a Mars mission? And is it prudent to first test capabilities days away when you're on the moon before attempting a mission to Mars, which would be months or years away from Earth, in case problems arise?
Congressman Babin, as the saying goes, I may be a little dumb, but I'm not stupid. No, we went through this in great detail, and the moon is only 3 days away.
Yes, sir.
And if you have something, there's a way possibly to get back, or other ones to help you, and you're in direct communications. And for example, we said the condition to the, we'd have a small space station that would be there for the period of time it would take to go to the moon, a chemical rocket at the right time in the year. And you can't go there every year because there's a 15-year period of energy,
Right.
sinusoid. And you can only launch every 26 months, but right now the lowest point and the best energy was in 2016. And so the next time is 15 years later,
Yes, sir.
2031. And the worst time is 2024.
Well
So,
said.
Anyway, we'd go for, say, 260 days or so in a small, like, station around the moon. This is one place where the gateway might be feasible. There's a lot of things I think is not feasible about it. But, and then we'd land, and then to simulate 38% gravity versus 16%, we'd have just weights on the shoulders, just like football players train with weights. That would bring your weight from 16% to 38. So right, we'll tell you how mobility, and this is just a simple thing. We
Yes,
would
sir.
do other things about that. So we think it's imperative. And also you have to learn how to recycle your oxygen and recycle the water. We're doing a lot of this on the space station, but we need to get the efficiency higher. So
Okay. Yes, sir. Thank you very much. And Mr. Young, your testimony states that management and contracting experiments must be excluded from the Mars Moon program. Can you expand on that a little? And is the Next Step broad agency announcement for human landing systems an experiment that would introduce unnecessary risk to the program? Turn your mic on.
Co-pilots and pilots are supposed to guide each other here. NASA has extraordinary capability that should be fully utilized in executing the program. That's kind of number one premise. And industry has extraordinary capability in implementation, which should be utilized. So I'm not a fan of an acquisition process that basically is training industry to do the job that NASA has historically done. I'm in favor of acquisition process that makes maximum use of both capabilities. As an example, a management experiment, in my view, would be to buy seats to fly to, for crews to fly to the surface of the moon. I personally think that these should be government-acquired assets under the leadership and direction of NASA, with industry having a full capability implementation. I think commercial cargo, if I went back to that, was an experiment that was worth doing, and in my view, if it didn't work out, it failed soft. Commercial crew, in my sample, is not the kind of concept that I would propose or support that we implement for the lunar program.
Yes, sir.
So I'm working off maximize probability of success, utilize all the capabilities you have to do that.
Thank you. Real quickly, General Stafford's testimony states, the leadership capability at NASA must be augmented at headquarters and at applicable centers. Mr. Young's testimony states the challenges of the Moon-Mars program are such that the leadership capabilities of NASA must be augmented. What exactly do you folks, you gentlemen, mean by that? And would you elaborate on that and how the administration can improve its leadership and augmentation?
Right, Mr. Babin, I'll start. When we pulled in Mr. Webb and the administration pulled in the best talent available, and that was General Sam Phillips. And he had managed the B-52. We built 740-some B-52s, and he's the one that put the 1,000 Minuteman in the ground. So he had tremendous experience. And I know of nobody that has the experience of General Sam Phillips today. And we were fortunate, too, down at Marshall Space Flight Center. We had Dr. von Braun, who had, his team had designed, developed, and produced 6,000 V-2 rockets in World War II, and then started the Redstone rocket here in the States, our first ballistic missile. I don't know of any talent like that available, so it's going to be tough to augment. We did have Bellcom, as Mr. Young mentioned, came from Bell Laboratories. It's Bell Laboratories that started the idea of systems engineering. And so they had, I think, up to 500 people, Tom, here at headquarters that would help them. So
Yes,
I'll
sir.
turn it over to Mr. Young.
If I could add to what General Stafford has said, the first thing I want to make it clear is that this is not a criticism of the current NASA. It's a recognition that a Mars human program is probably the most challenging thing we have ever done as a civilization. I mean, we just can't underestimate what a challenge it is. I think achievable, a challenge. Even returning to the moon, it will be a challenge. So what that says is we've just absolutely got to have the best that the country has available. And what that says is that we need to augment the current NASA capability like we did on Apollo. And if we don't, then we're probably embarking upon something that we should not embark upon.
Thank you very much. I'm way over. Sorry.
That's okay. Thank you very much. And Mr. Babin, thank you. The chair recognizes Chairwoman Johnson for 5 minutes.
Thank you very much. Mr. Young, we're here today to get your perspective on the most effective and sustainable path forward for our nation's human exploration program. And you have commented some on that. But I'd like you to tell me your thoughts of what should be our exploration goal and the timeline. Give us your perspective.
Good question, thank you. My personal belief is that the most compelling opportunity is humans to Mars. I also, as I just mentioned, respect and understand how challenging that is. And I believe that we certainly can maximize the probability of that mission by lunar activities. So I'm an advocate of the lunar part of the program being preparatory for the Mars part. I do have a worry that it's possible that we could get bogged down at the moon. So I think we really need to clearly define what it would be. So if I were personally writing the goal that you talked about, it would be human boots on the ground at Mars, and that we should implement those things that are necessary, like the lunar program, to maximize probability of success, and also recognize that we do need intermediate milestones where we can demonstrate success as we're going along. I'm going to cheat with time, but just to add, I've thought a bit about, Apollo had the advantage of an international competition with the Soviet Union. So what drives us to do a similar kind of a thing for Mars? And there are a lot of reasons: science, geopolitical. My personal belief is that today we live in a very challenging, complicated world. And it is possible for a young generation to be discouraged and even depressed by some of the things, and I don't see that changing. And to have an objective of something like humans to Mars seems to me is the inspiration and the beacon and the bright light, and it's a way to tell our generation and your old generation, to tell the future generations there's a lot of opportunity that's out there, and don't be turned off by just the fact there are an awful lot of challenges, because, humans to Mars is just an incredible endeavor. And I can go one step further. I can envision every day the crew, to keep them sane, communicating with us here on Earth, telling us what's going on, and that in itself, kind of allow all of us to participate in the trip to Mars. Thank you.
Thank you. Don't take up my time with this. General Stafford, what lessons do we need to take away from the Gemini and Apollo programs that we consider a structured and effective Moon-Mars program for sustainability and success? As we think about where we are today with our human exploration program, what, if anything, do we need to change?
Well, Chairwoman Johnson, it's a very good point. So I sat in this room and look around to Chairman, and I see pictures of Chairman Teague there from Texas, one of the great chairmen. And I think I testified for him 3 or 4 times, and he said, "What should we do to keep going?" I said, "One thing, Mr. Chairman, is to have consistency." And that's what we had in both Gemini and Apollo. We had consistency. And we need consistency in funding, resources, support, legislative, and all this to keep us going. We have to have that, because, as pointed out, as President Bush started the Space Exploration Initiative, then the next administration under Clinton came in, he basically terminated it, and so exploration languished for 8 years, and then we started back up after about 3 years into George W. Bush's administration, and we started rebuilding our systems engineering and sustainment. It went up, and then the next, his 8 years were up, and then budget was cut right away and down, and the Constellation program that it started to build, and it was building a big booster out of parts of the shuttle, part of the Saturn, but it went down. And so you have to have consistency. That's the main thing. And also realism, like when one of your opening statements, you said you have to learn from the past, like I said from what George Santayana said. You're going to repeat the lessons of history if you don't learn from them.
Thank you very much. My time's expired.
Thank you, Madam Chair. The chair recognizes Ranking Member Lucas for 5 minutes.
Thank you, Madam Chair, and I want to continue down, I think, essentially the same path a number of my colleagues are going. NASA's requiring that the human landing system to launch aboard commercial launch vehicles rather than the more capable SLS. That means more launches, more on-orbit rendezvous, more on-orbit assembly, fails to leverage the investments that we've made in SLS. General Stafford, you conducted some of the first on-orbit rendezvous during the Gemini program and flew aboard Apollo 10, which conducted the dress rehearsal of Apollo 11 and chaired the advisory committee in the 1990s. So safety is an issue with you. Could you touch for a moment, if we're going to go with that smaller system for doing things, what do multiple launches and multiple on-orbit rendezvous, how does that affect safety and risk potentials of postures for the lunar landers?
Mr. Lucas, that's a very good question, and the mission I did encompassed the whole thing with one launch. And I noticed, reviewed the material that Mr. Cook testified for this committee, I think a little over a month or so ago, and outlined it, and there's 8 launches required under the present architecture. Only one of the big ones, the rest are small ones. And the probability of success, as he outlined, and I cannot disagree with it, was only 50%. And I certainly would not want to start that. In Apollo, we had a goal of crew safety of 999 and mission success of 0.90. And if you review what we did on Apollo, we had, the first mission was just on the small Saturn Earth orbit, but on the big Saturn, we had 10 missions, and 9 of those were successful. We had Apollo 13. It was a success to bring the crew back. We hit the 3 nines on bringing the crew back, but the mission failed to make the 3rd lunar landing, so we were right there at 0.9. But with 8 launches, to me, I'll have to go with Mr. Cook. Your probability of success goes down to about 50%.
Oh, my. Mr. Young, to continue down the path of your comments and your testimony, list, of course, a number of recommendations to ensure that NASA plans move forward in a successful way. One of those recommendations is to prioritize human spaceflight activities. Could you discuss for a moment, if NASA does not get additional funding and the ISS operations are extended to 2013, I think I know the answer, but for one more time, will this delay deep space exploration?
Got the button. Absolutely. It will delay it. It will delay it significantly also. Yeah.
General Stafford, on Apollo 10, you flew closer to the moon than anyone ever before. And of course, this gave you a unique up-close perspective of the moon's geological features, the craters, the boulders. And this informed the final landing and provided scientists with important information. Will a return to the moon teach us valuable information about the moon and the Earth?
Mr. Lucas, absolutely. And in the book here we had, our charter was to give the 2 or more architectures and the technology priorities. In other words, how do we go back to the moon? And but about 4 months into the year's effort we had, it became obvious to us we have to say, why should we go back to the moon? And so that is included in this book. And what we would learn from it is really a tremendous amount of knowledge, and also and what you can do from it is unbelievable. And it takes too long to go into the details. They're all inside the book there, sir. But yes, there's reasons to go back.
One last question, General. I know it's been a day or two since you did it, but that must have been a tremendous view out the window of that lander.
Well, the lander was unique vehicle, Mr. Lucas. It was a very flimsy vehicle, unpressurized. You could take your thumb and push hard between the frames and the skin would blow out. And then we only flew at 5 pounds per square inch pure oxygen. And when you did that, you see the rectangular hatch in front of you where you crawled out, it would bow out. It was not meant for, airline type operations. It was made out of very thin material, and it worked one time, but it did the job, and it did the job real well. We had 6 successful landings. We brought back 842 pounds of rock and material from the moon, and from that we have certainly learned a lot.
Thank you, General. Yield back the balance of my time.
Thank you, Ranking Member Lucas. The chair recognizes Mr. Perlmutter for 5 minutes. And he's going to pull out his, yep, there it is. There's the bumper sticker. I knew it was coming.
Gentlemen, thank you for your testimony today. I kind of feel intimidated by the two of you being here and sharing with us your thoughts and your knowledge about all of this. And, clearly, General, you talk about consistency. And from administration to administration, it kind of varies and changes. And quite frankly, I think it's our responsibility as members of Congress who are here, and this institution goes on and on and on, for us to set these unambiguous goals with a national, international project such as this, because it's huge and it's going to take a long time to really get the pieces. It's going to have a budget that is worthy of the tasks that you're undertaking. So Mr. Young has seen my bumper sticker before, and we talked about repeating history, but the other side of that is the fact is we did do it with Apollo and Gemini and Mercury when we didn't have nearly the capabilities that we have now. And so my bumper sticker says 2033, and the small print you can't see. This is Mars over here. It says we can do this. We can do this if we have consistency of purpose and unambiguous goal, and Democrats and Republicans, together with the people of the country and the world, say we're going to do it. We will do it. So my question to you, I'll start with you, Mr. Young, and I really, your testimony, both of you, I just, again, re-energizes me to go just be persistent as hell about doing this. So you talked about the need for kind of public involvement in this. How do you think NASA's doing in engaging the public? Can they do more? Should there be more done?
It's kind of a hard question to answer. My observation is that Administrator Bridenstine has gone above and beyond in interacting with the public, giving speeches and advocating strongly for for the program. So, in that regard, I would say a positive. So I guess that's kind of the limit of my observation. I'm on the outside looking in, but I do think the advocacy, has been quite positive. I think that the early making some progress on some of the items that I identified in my testimony have not been, as actively, engaged with, and I recognize the difficulty. I am struck by the fact that the Vice President's speech was 6 months ago. So, and I guess Tom Stafford would remind me again, there's nothing more useless than runway behind you and altitude above you, and it's also time behind you too. So I think we really do have to, function with a high degree of urgency. I'm an advocate for mission success, but I'm an advocate to balance that with urgency. And so I guess I'm rambling, but my general comment is I think that the support for the program has been strong, but a lot of the actions that I think that are necessary are yet pending.
Any thoughts, General?
Well, I agree with Mr. Young, and Mr. Bridenstine has been out there really, putting forth the the rationale, the reasons, and for the exploration. But we still have a lot of actions to go. And when I see this one architecture, I don't know how it was put together, to have 8 launches to do one landing, that kind of concerns me a great deal, sir.
Well, and I think, again, from just sitting up here and being a member of Congress, I mean, our responsibility is to provide funding so that the agency, as the lead of this, and I think it's going to be international in scope and public-private, it's going to require all of those things to maximize the success. But I'd love to have you two go with me, and I'll grab, somebody over there, Dr. Babin, and we'll go from appropriator to appropriator to talk about this being the kind of thing that can bring a lot of people together because it's so aspirational, if you will. And with that, I'm going to yield back to the chair because I could go on forever on this thing. So,
May I add one thing to that?
Of course.
Sir, over the years, I've had so many people come up to me, said the reason I went to college, I saw you in your group fly Gemini and Apollo, and I saw what you did. I wanted to be part of it, or at least support part of it. I mean, there's literally hundreds of people said they went to college and studied and all this.
Absolutely. Thank you very much. Thank you, Mr. Perlmutter, and thank you, General. The chair recognizes Mr. Posey for 5 minutes.
Thank you, Madam Chair, for holding this hearing on deep space exploration that involves going back to the moon and then to Mars, and for accommodating these 2 great, awesome witnesses that we have here to share with us today. To achieve the ambitious deadline of putting boots on the moon in 2024, I think that we all agree that we all must do everything we can to ensure that there's sufficient funding to do that. I think that's where the buck stops. Will we have the money to do that? And I agree with our esteemed witnesses that both the administration and Congress must continue to fully fund the necessary assets such as Space Launch System, Orion Crew Exploration Vehicle, Exploration Ground Systems, Mobile Launcher 2, and the Lunar Orbital Platform we refer to as the Gateway, to ensure that we stay on track to meet those targeted launch dates. In addition to fully funding the critical space assets, I think we need to ensure safeguards are in place to protect the astronauts from radiation in deep space, as well as the other hazards that are inherent to such missions. And with NASA's strong leadership and a firm commitment from Congress, I think we can do that. Questions, General Stafford and Mr. Young, 10 years ago, the National Academies of Science conducted a review of risk posed by radiation exposure during crewed deep space exploration. They evaluated shielding options, mitigation techniques, and recommended strategies for future missions. Do you think the state of science has changed since the last assessment? And if so, would it be helpful to revisit the subject and seek further guidance or updates?
Well, even though I'm not a medical doctor, let me tell you the information here at the sea level at our latitude. We receive approximately 6 millisieverts of radiation a year. In the space station or in low Earth orbit below the Van Allen belts, you get about 0.6 of a millisievert a day. So in other words, in 10 days, say on board the space station, you get equal to 1 year on the ground.
Wow.
Now, for the 24 of us that flew beyond the Van Allen belts, once you get out there, you get about 2.6 millisieverts a day. So in 2.25 days, you get equivalent to a year on the ground. Now, from this study we did, we had the Department of Energy come into us, and medical doctors from radiation expertise, and they said that they use the term 16 grams per centimeter cube. Well, I think kind of from Oklahoma, different inches per, pounds. So it equates to about 1 foot of water would protect you from all solar radiation. And you could use that 1 foot of water in, say, an inflatable and recycle it. And you have to recycle the water, just like you use 2.2 pounds of oxygen a day, you need about 6 pounds of water a day. That water would be enough to shield you very well from the solar radiation. Now, cosmic radiation is a whole different ballgame, but that's not near as prevalent.
Okay. Ms. Young,
I don't have anything to add.
tough to top that one for sure. General Stafford, as someone who's actually flown a lunar landing module during the Apollo, and I had the honor and pleasure to work as an inspector on the 3rd stage of your rocket back in the day. You have unique insight into what we need to be considering now as we begin to build a lunar landing module for Artemis. And wonder if you could identify the key lessons from the development of the Apollo lunar module that we need to incorporate into the current architecture. You know, may it be key safety, testing, oversight, you know, requirements that are necessary for these complex missions that might stick out in your mind.
Well, you hit on a lot of them right there as far as inspection oversight, but you have to start with, you want to keep things as simple as possible, even though it's a very complex subject to work with. And you can't let anything sneak up on you. And you have to have great quality in everything you do. As I pointed out, I don't, in my own opinion, and also what Mr. Cook said, that I don't think that starting with 8 launches to put a series of 4 small things together is going to be the right way to go. Okay. Let's take an example, the space station. It weighs about 900,000 pounds now, but yet nearly 30% of that weight is in the coupling devices to keep it together. Okay. So you want to keep the things as simple as possible in the units. And say if you have these 4 units, each one has to have a electrical power system, a reaction control system, a docking mechanism on them, all of this, and a propulsion too. So you're, versus just an Apollo, in the lunar module, we had just one guidance system. That took care of the whole thing. Yeah. One RCS system.
Well, that was a miracle, General. You know, almost a miracle. Thank you, Madam Chair. I yield back.
Thank you, Mr. Posey. The chair recognizes Mr. Olson.
I thank the chair and welcome Mr. Young and General Stafford. General Stafford, as you know, on Monday, our nation celebrated Veterans Day, and you are an amazing veteran. I want to thank you first for your amazing service to our country, and especially 507 hours and 43 minutes in space on Gemini 6, Gemini 9, Deke Slayton's ride, Apollo-Soyuz, and has been mentioned over and over, Apollo 10. Y'all did everything to land on the moon except for actually put the limb down. Got down there, I talked to Gene Cernan, he thought about shooting the approach, but guess what? The guys back in Florida did not properly fuel the limb to have a landing come back, so thank you for going that. Also, I know it's tough going out there because on the way out, you had to catch something floating through the command module. I'll leave that to yourself to explain what happened, but the glorious space flight. Also, Mr. Young and General Staff, you all mentioned the power to motivate our young people seeing human beings in space. I say all the time back home, I work right by the Johnson Space Center. I grew up right in the shadow of the Johnson Space Center. I show kids, this is not to slam other missions, but I show kids the Mars rovers, which are great. We learned so much about Mars with those Mars rovers. Then I showed them Bruce McCandless out there with a jetpack. Bruce McCandless, rocket man. Everybody wants to be Bruce McCandless. And so we can't put a value on that persona that NASA gets. We have to tap into that to go forward. You've chaired the ISS Advisory Committee now for the past couple of years. And my question is, how can the ISS help us out going back to the moon and going to Mars? And we're trying to extend that. How to make sure that happens. Also, it's been so, going to the moon, that was all us, all America. International Space Station, that's international. That great arm, that came from Canada. Russia's thrown our guys up there, cargo vehicles, manned vehicles, Soyuz vehicles. How about some international help going back to the moon and possibly to Mars?
Well, thank you very much, sir. Yes, I think international help can be there, but they also have to be on time.
And pay.
Yeah, and pay. One thing, the space station, I'm very proud of what they've done. They've helped solve put us on the way of solving the problems. As I mentioned, 2 pounds of air, 2.2 pounds of air you use every day, and about 6 pounds of water. We are recycling the air, recycling the water. We've learned how to do that now on the space station. We still have to increase the efficiency to get it, but the space station also, we've learned now this called an ARAD, astronaut exercise reactive devices, like pumping iron in space. And with the proper diet and also some pharmaceuticals, you can keep the muscle mass up, the red blood cells up, everything else. So the space station has put us way up here as far as knowledge for long duration missions that can take us to Mars.
And Gene, sir, your crewmate there in Apollo 10 echoed your comments about the best place to train for going to Mars is the moon. As you mentioned, gravity, our moon is 1/6, Earth about 1/3 of Earth's gravity. Also, we found out since the Apollo missions, guess what's all over the moon? Water. Okay, so comment about how much going to the moon, is that an important step to going back towards Mars? What can we learn by going back to the moon that helps us get to Mars as quickly as possible and safely as possible?
Well, it'll teach us on first working in deep space beyond the low Earth orbit. And from that, again, the equipment and how long, the reliability of the equipment, what we need to do, and it's going to be a whole series in which I've listed here, sir, to take a lot
Oh, yeah, yep, the Bible.
to go into it. But definitely, I think trying to go to Mars, not going to the moon, is really a no-brainer not to do it.
Question, Mr. Young. I'm concerned about the SLS for one reason. As Mr. Stafford mentioned, the vehicle went to the moon on was the Apollo, the Saturn V rocket, designed for one thing: take 3 people from here to the moon and back with the lunar module, and later missions with the lunar rover. Okay, we built this rocket for one mission. The SLS is designed to go to deep space. So any concerns about just having generic mission as opposed to build this rocket to hit this exact mission? Adapting the SLS to going to Mars maybe, which we're hoping you can do, but
My observation is that SLS, does have the capability to go to, to support a deep space
better.
mission such as Europa. But I think that, my observation is that the focus of SLS has been a heavy lift capability aimed primarily at being able to support a lunar and a Mars human mission. And in addition to that, it also has a capability, which my guess is the Saturn V would have had that capability also, to do missions that require heavy lift capability to minimize flight time, which is the Europa situation. So my observation, and I appreciate Tom's comment, is that I don't think that SLS has been compromised from its primary use of humans to the moon and Mars.
thank you. Mr. General Stafford.
Let me add that, in the 2010 NASA authorization, it said start with a minimum, and the word is minimum, of 70 metric tons to grow to a minimum of 130 metric tons. Now, 130 metric tons is just nearly what we had on the Saturn V. But it does have the capability to increase even beyond 130 metric tons. They can go up to, but you have to get that enhanced upper stage built and go on it.
Mr. Chair, one final question, Mr. Chairwoman, for Mr. Stafford. You're sort of an odd duck, sir, because you went to the Naval Academy and then joined the Air Force. So based on your experience there as a midshipman, as you know, in the next 4 weeks, there's this big football game between Army and Navy. So in your humble opinion, who's going to win that football game? Any idea?
Sir, I just could not forecast on that.
I can for you. Go Navy, beat Army.
General, he likes to stir up trouble around football games. You should probably know that. Although he has been wrong already this year. Thank you very much. Gentlemen, I have I have a few more questions. If you'll indulge us a little bit longer, I think I want to express our gratitude for your wisdom and candor and all of the work that you've done. This has been incredibly informative, and I don't want to speak on behalf of everyone up here, but I think we've all thoroughly enjoyed it and found it incredibly helpful. And there were a couple of other points raised in your early testimony that I'd like to follow up on just for a moment. Mr. Young, when you were talking about how we can streamline and increase the probability of success. You have experience clearly in government and industry. You've gone back and forth, and you've been there over attempts to streamline and improve systems and acquisition. And in your experience and in your view, what can Congress do to ensure transparency in the Moon-Mars plan and an acquisition approach that provides that consistency that we've talked about, consistency and also oversight and accountability over the course of a long-term program?
Few observations. First off, to the consistency. I think that one of the things that maximizes consistency is a high-quality plan where all people have a strong appreciation of what's really being pursued. And so I think that, that's probably, I guess I should really back up and say an unambiguous, clear goal coupled with a plan that is well laid out and is very clear, so that there's no real debate as to what it is that's trying to be accomplished. Relative to, the overall process of, as I mentioned earlier, I'm a big advocate of using all the resources you have available. And what that really says to me is that, NASA's an incredible resource. And NASA should not be in the role of just oversight or just simply standing back and allowing industry to make decisions that, in my view, should be NASA decisions. So I'm a real advocate of utilizing all the capabilities exist, which says maximum use of NASA, but also recognizing that NASA is not a manufacturing, NASA's not an industry, and we should maximize the use of industry. We touched on a little bit today, there's a lot of discussion around, commercial and the new commercial, paradigm. First of all, I think that we should all applaud what the commercial people are doing, that it is terrific. But I think in an endeavor that is so challenging and complicated as this, we really shouldn't confuse it with trying to enhance commercial or not enhance commercial. So my view in that regard is all organizations industrial organizations that have a capability to contribute, competition should be open for them to compete, and the absolute best should compete, but they're competing to be part of a team led by NASA. and that the procurement should be consistent with that. And NASA really shouldn't be sitting in the back of the room observing. They should be sitting in the front of the room leading.
Thank you very much, Mr. Young. Just a couple more questions. General Stafford, first of all, thank you again. It's truly an honor to hear your experience and watch the way that your brain works, and being able to go over some of these really complex ideas and boil it down for us. In your view, what are the top 3 actions that need to be taken now to structure and implement a Moon-Mars program for sustainability and success?
Oh, Chairwoman Horn, number 1 has to be an adequate plan, as Mr. Young has pointed out, a real adequate plan. Number 2, we have to have the funding to go with it. But number 3, we have to have the talent to manage this. And that's the one thing that made Apollo go. We had the talent. And really made Gemini go. In Gemini, we did 10 missions in 20 months, which is a real tremendous pace. But when we went to Apollo, it was even faster. From the first Apollo flight, I was a backup commander on that. We did, in just 9 short months, 5 missions. And 3 of those were to the moon, and 3 of them had 2 spacecraft each on them. And we carried out in 9 months and landed on the moon. 5 missions, 9 months of the giant, and we flew on the giant Saturn V. So you have to have the plan, the resources, but you have to manage it. And this is where Mr. Young pointed out, and I pointed out about how Bellcom came in and did that, and other people.
Thank you very much. And my final, I know I'm a bit over, but my final question is, well, I have many more, but I won't keep you here all day. Is you mentioned it's something that we haven't come back to. We touched on a little bit. General Stafford and Mr. Young, you both mentioned it. Perspectives on the role of a gateway in a Moon to Mars program, and how important is the gateway, and is there a role for international participation here? Can you turn on the mic?
Back on, okay. I think that I do not really see a required role for the Gateway in the lunar program. I do see a role for the Gateway in testing habitat modules, et cetera, for the Mars, for Mars activity. So when I look at this full plate that I talk about, you know, Gateway would be one of the areas that, if I were there, that I would look carefully at as to what are the real contributions of it to the overall success of the program. So I guess what I'm saying is that what I know from the outside looking in, the Gateway, there's not a compelling argument to me for the Gateway for the lunar program. It is to have capability to test close to Earth some of the critical components for the Mars mission, so it would play a role in that regard.
Thank you, General Stafford.
Well, one thing on the present plan, they have a cycling into this orbit called a near rectilinear halocentric orbit, which has a period of 7 days. And so you have to be able to get to that. Now, I performed the first rendezvous in space ever. And around the Earth, you go around about 89 minutes. You could call it close to an hour and a half. And from that, we started out using a Hohmann transfer as demonstrated. We had big arrows possible at the end. It turns out we used a Russian technique. It was in a published version. They came to me, and it was all in Russian, but I didn't understand one word, but I understood the orbital diagrams. It was said, rendezvous using the theory of co-elliptic concentric orbits. And that's basically what we did, only we simplified the end of it, we'd have an inertial line of sight. In other words, with respect to the stars, that's inertial, they're fixed. And so it's like flying an instrument landing system for those of you that are pilots. You have kind of bars, and so if the bar goes up, you pull back on the stick and go up here, you just thrust up. So it became very simple for a pilot to use. And at a certain angle, you'd thrust towards it for the terminal phase. And so I did the first one on Gemini, I did 3 different types of rendezvous. And one of them I said, don't ever do again unless it's emergency. That's an overhead ballistic intercept coming down. And then I did the first rendezvous around the moon. And so, and then also I did the first international. I've done, because of assignments, more rendezvous than anybody in the world. And I think I understand it very well. I have some serious questions about this rendezvousing out in deep space. I won't say it's impossible, but I haven't yet seen what the simulations of it or how you would do it, because we use the breaking out from in the darkness in the sunlight and the stars as a background and the target and all this. And out in deep space, it'll be a different. Of course, you can have, but now star trackers that can help you. But we could launch about any time off the moon and get back, at least once every 2 hours, because the orbital period is 2 hours around the moon. And here, 7 days, you can't launch every hour. And it's going. And the only way you're going to change things is using, instead of orbital mechanics, you're going to be using a lot of propulsion. So I don't know the answer to it. So I'm just saying I've got questions. I will say, let me add one other thing. They use the word, quote, commercial. In Apollo, everything we flew on, everything we did was commercial. It was all done by commercial companies. NASA did not build a thing. And maybe it's a few little hand tools we used on the moon, and that was it. And so everything was commercial, but yet NASA, as Mr. Young pointed out, had the lead and showed the way to go. And what really worked out was on the Saturn V, how good it did, and the Von Braun team did an unbelievable job. Also, the way NASA's team recovered after the tragic fire. But NASA had the lead, and it was commercial.
Thank you very much. I truly, it is an honor to hear from both of you. Your experience, your expertise, and your insights are critical, and I think anybody that wasn't here today absolutely missed out, and I hope they watch the hearing later. And before we bring the hearing to a close, I want to again, I think on behalf of all of us, express our gratitude and for both of you. So thank you. And I should remind everyone the record will remain open for 2 weeks for additional statements from the members or any additional questions that the committee may ask of witnesses, if you would do us that favor. And the witnesses are now excused and the hearing is adjourned. Thank you.